Okay, so we're looking at this vector field, negative yx. And so very quickly, let's try to draw a picture of this. In fact, I think we did draw a picture of this at some point. You notice that the vector field vector and the position vector have the same magnitude and they're perpendicular. Right? And so in fact, the vector field, at a given, wherever you might happen to be, the vector field points sort of counterclockwise, around. So it represents a flow of a fluid that's counterclockwise. Is that cool? Okay. Yeah. Okay. Anyway. Compute the line integral around the unit circle oriented counterclockwise. So, okay. Well, you could try to find an anti-gradient, and you're going to fail, as it turns out. So, I mean, that's worth giving a shot to, by the way, to play the anti-gradient game, and just realize that there's no way to win that game. All right, so you have to chapter 5 this thing, and unit circle counterclockwise. X is cosine t, y is sine t. T goes from 0 to 2 pi, and brute force, plug and chug. Is that cool? Okay, so that's part 1. All right, let's see. Suppose now that this were the gradient of some function. We've already kind of at least agreed that we don't think it should be. Okay, and suppose we consider the curve C as starting at 1, 0 and ending at 1, 0. Okay, yeah, let's draw a picture. Starting at 1, 0 and ending at 1, 0. What would the fundamental theorem of line integral say about this line integral? All right, well, this line integral over that curve of this vector field dx, if that vector field were the gradient of some function, and here's where I'm, where I'm using that, there. So if it were the gradient of some function, then, well, the fundamental theorem of line integrals would say that this line integral would be f of 1, 0 is the ending point, minus f of the starting point, also 1, 0. That would have to be 0. Does that make sense? Yeah. So now let's ask the question, is it possible? Well, we already computed one of these line integrals, and we got not 0. Right? So if it were a gradient, the computation in part 1 would have had to give me 0, but it didn't. Does that make sense? Yeah. So it can't be. So the answer to this question, is it possible that an anti-gradient might exist? No, it can't be an anti-gradient. All good?
Okay. In the fourth.
Oh, there's a fourth part. Oh, yeah. Okay. Sorry, I didn't see that. Suppose you need to compute the line integral of the same vector field over some other curve. Yeah, well, so the answer is no. Don't even think about using the fundamental theorem of line integrals, because we already agreed for this earlier discussion that there is no anti-gradient. And if there is no anti-gradient, then the fundamental theorem of line integrals, of course, requires an anti-gradient. So if there is no anti-gradient, then you can't use the fundamental theorem of line integrals. Yeah. Everybody good?